we got alpha, beta, gamma also. Very good. So let me write down what was we got AB, which is 5.2024 Pascal mole cube per meter cube per mole square. We have P, which is 1.4750 10 to the power minus 4 meter cube per mole. We have capital A, which is 8.8398 10 to the power minus 2. Capital B, which is 8.9151 10 to the power minus 3. Alpha is minus 0.9911. Beta is 7.0329 10 to the power minus 2. And gamma is minus 7.0789 10 to the power minus 4. Okay. So P is, so now x cube plus alpha x square plus beta x plus gamma equals to 0. That's the point we have, right? And we have to find out P, Q, and then to get D, right? That is discriminant. So what is P? P is beta minus alpha square by 3, right? P is beta minus alpha square by 3. How much is coming? Beta minus alpha square by 3 minus 0.257 on that. Then you have Q, which formula is, you have the formula with you. You should tell me the formula. I won't tell you the formula. The formula is 2 alpha cube by 27 minus alpha beta by 3 plus gamma. 2 alpha cube by 27 minus alpha beta by 3 plus gamma. So it is coming as minus, should be having take the minus 2 order. What is that? 4.9. It's plus or minus? Minus 4.9584 to the minus 2. 9584 to the power minus 2. Then comes D. Immediately. This P cube by 27 plus Q square by 4, right? Based on the formula. Is the formula handy, right? P cube by 27 plus Q square by 4. P cube by 27 plus Q square by 4. P cube by 27 plus Q square by 4. How much is coming? Minus 1.4677 10 to the power minus 5 minus 1.4677 10 to the power minus 5. Okay, what should we do then? What's the solution technique? Yes, then which one? Case 1, case 2, case 3. Please go by your class notes. Your notes, everything is there. 3, that means what we have to find out? If it's case 3. Yes, you are right. So what is R? Square root of, not minus, square root of minus P cube by 27. How much it is coming? How much it is coming? minus p cube by 27. It should come positive. Yes? Just one answer, please.
Why not 2?
Yes, 2.5088. Again, you are doing the same mistake. 2.5088 10 to the power minus 2. Cos theta. Formula is cos theta is minus q by 2 into minus 27 by p cube whole to the power half. Minus q by 2 minus 27 by p cube whole to the power half. Whole to the power half, how much it is coming? Theta should be in terms of radians. Pardon? 0.9882 is cos theta. Theta in terms of radians, as I said. Cos inverse. So many answers I am getting. 0.982 is up to this is correct. Here after I am getting 2-3 varieties of answer. Answer should be only one. I don't know that particular answer I am looking for. Cos theta is 0.9882 and theta should be in terms of radians. Theta should be in terms of radians. Theta should be in terms of radians, yes. 9.42 radians, huh? 0.16. How did you get it? 0.16 one answer. He gave 9.2. 9.4. Any more answer? That's 0.15. Oh, excellent answer. 0.1533. Oh, perfect. Perfect answer. It's not 0.16, 0.1533. How did you get now?
Change the mode into radians.
Pardon?
Change the mode into
Yes, radian. That's why I said change the mode. You have a calculator. You change the mode to radian. That's why you need the calculator handy. Okay. Now we have got z theta. Now z1, z2, z3 will be very easy to find out, right? The three values of compulsory factor: z1, z2, z3. Z1, what's the formula for Z1? 2r to the power 1/3 cos theta by 3 minus alpha by 3. 2r to the power 1/3 cos theta by 3 minus alpha by 3. Theta by 3 is 0.1533 divided by 3 and then you take the cos. Let me check the answer. I want to have the final answer, Z1. I want to have the final answer, Z1. 0.9153 somebody is getting. 9194 your somebody is getting. 0.9158 somebody is getting. 0.915. Okay, Z2. Z2 is 2r to the power 1/3 cos 2 pi by cos theta by 3 minus alpha by 3. And third one is 2r to the power 1/3 cos 4 pi cos theta by 3 minus alpha by 3. Z2 is how much? No. Please give the answer in the -2 form, exponential form. If it is not 0.1 or something like that. Z2 and Z3 I am waiting for. Pardon?
1.47.
Yes, madam. 10 to the power?
Minus
What's about you?
1.24.
I'm getting 1.24 to minus 2.
1.21 limited to minus
1.21 to the power minus 2. Z3.
6.39 to the power.
Now tell me what is ZL and where is ZL and where is ZB? Where is your ZL and where is your ZB? ZB should be maximum, ZL should be minimum. Correct? This is the spurious mixed big point. We don't have to know. So you got these two interesting stuff, ZB and ZL. Now with this, you know the formula for Payne-Robinson I have given in the morning. Payne-Robinson fugacity formula. Fugacity coefficient of Payne-Robinson, which is PREOS ln phi, which is z minus 1 minus ln z minus b minus a by 2 root 2 b at t ln z plus b into 1 plus root 2 by z minus plus b into 1 minus root 2. So if you look at this fugacity coefficient formula, if you put A here, it will be L, that's all. Because capital B is dP by RT. Pressure is there, system pressure, which is 0.215 megapascal, right? And capital B is already calculated, is same. Okay? For pressure is system pressure is there. It is a function of system pressure. R and temperature. R is fixed, temperature is fixed, system pressure is fixed. So capital A, B, everything is there. So only thing is varying. This Z. Okay? If you put ZL, you get phi L. If you take exponential, and you get phi B. So what is? I will first ask ln phi L. ln phi L. ln phi L. It will be first term will be 1.2106 to the minus 2 minus 1, then minus ln of z minus b. Capital B is already calculated as 8.9151 minus 3. So please put it and give me the answer. If you calculate phi L, then from there, if you know system pressure, you know phi L, from system pressure you can get FL, which is FL by P, which is phi L. You know system pressure, you can calculate the FL. How much is the phi L? ln phi L. First we find out ln phi L. Please use the memory function. Evaluate the last term. ln mod of z plus b into 1 plus root 2 by z plus b into 1 minus root 2. Keep in memory 1. Then ln z minus b, keep memory 2. Z minus 1, memory 3. Then you subtract or add. Memory recall. You can get the final answer. Do it. Enough. How much you will get the ln phi L? First you calculate the first put the memory function of the last term. First you put the memory function in the last term and then the subsequent terms. Rahul रहेगा Yes. Ln phi L. Ln phi L.
Ln phi L is 1.7.
No, completely wrong. Ln phi L. Do it slowly, don't be smart. It's a very heavy calculation. You keep, best thing is each term you just keep in your notebook. 3 terms. It's better. Ln phi L, it should be negative for your information because you have to get the fraction of FL. A maximum value should be 1 of the phi, right?
Minus 15.8.
So high. No way, no way. Ln phi L. It's so high. So many answers I get, I know. How much? No. Put the values very carefully. Put the values very carefully. The last term you have small a, which is 5.2024, correct? Yes? 2 by root 2. B is what? 1.475 not to the minus 4, correct? Yes? R is 8.314. T is 4 to 7.85. Okay? You put properly all these values. If you are very careful of calculation, this fraction you note down in your exercise book from the calculator. Then multiplied by ln, which is 1.2106 10 to the minus 2 plus B is 8.915 minus 3 into 1 plus root 2. Divide by the similar way. Okay, this is the major calculation. Other calculation is very straightforward, which is ln z minus b. Z is 1.2106 minus 2 and b is minus 8.915 minus 3. Each term, please remember you are doing ln, not log. So ln and log you have to be very careful in the calculator. Log to the base c, not log to the base 10. Okay. How much you are getting? Any idea? So far I haven't got the correct answer. Ln phi L. The hint is phi cannot be greater than pressure, right? It should be fraction. So ln phi should be negative. Please write all the terms carefully in exercise book, otherwise you won't get the correct answer. If you want to do shortcut, you cannot do that. Every term, whatever you are getting from calculator, write it and then do the calculation business. Because this calculation is very straightforward. I don't think any unit conversion is there. ln phi? My God, you got the right answer up to 3 decimal. That's right. Up to 3 decimal you are getting correct answer. How to do it? It is, you have to done it correctly. Okay, thank you. It is minus 0.0978. Correct? So phi L should be how much? Phi L should be how much then? Anti-log or exponential of this. So anti-log means how much you are getting?
0.9.
0.9068. 0.9068. And Fl equals to how much megapascal? System pressure is 0.215 megapascal. How much megapascal? Fl. So phi is Fl by P. Right? You should be remembering all those. So Fl is phi into P. Then how much it is coming? Fl 0.195 megapascal. 0.195 megapascal. Okay, keep it. Remember that equilibrium F is to be equals to Fp. Now look at ln phi b from this Page Robinson. ZB minus 1 minus ln ZB minus B minus A by 2 root 2 B at T ln ZB plus B into 1 plus root 2 like ZB plus B into 1 minus root 2. Give the calculation. Give me the answer. Give me the answer. And we want to see what is whether Fn equals to LB or not. Whether Fn equals to LB or not. Then 5b. Similar way the calculation should proceed. Now you should be doing fast because I have already done it. Similar way calculation should proceed. Similar way calculation should proceed. Pardon? Minus 0.08 ln 5e. One answer. One answer minus 0.08. Only two decimals? No other decimals? Minus 0.08. 206. Right? That's what we are saying. What else? Any other answer? Minus 0.08206. So far, only one answer. Any more answer? Minus point? So then 5b is minus 0.0821. Okay. So 5b is, how much is 5b? How much is 5b? 0.9212 and FB equals to 0.1981 megapascal. You can see that they are not equal. So they are not equal. Since they are not equal, you can guess the new P new. Okay, and proceed further. So generally, when we started your system pressure as 0.215 megapascal. Okay, and then proceed further. Then that is, you are saying the system pressure itself is the saturation pressure. But we are seeing that that assumption itself is wrong. So you have to go for the new system pressure, which will be your system saturation pressure. Okay. So our algorithm says what? If we look at our algorithm, which says P new P equals to P over T FL by FB. This was the system pressure for the initial first iteration. It was the system pressure, which is 0.215 megapascal. You are seeing that at system pressure I am actually equilibrium. That will not be correct. Okay, and that is not correct. You have seen it. So what is your P new then? How much is P new? We have found Fn, we have found Fb from our formula. We know the P old. So what is P new? 0.2116 megapascal. Please tell the unit. If you don't tell the unit, it's a problem. Okay. So you got the new system pressure or new pressure, which should be likely to have your, because at the convergence, this P new you should write down at convergence. This will give the saturation pressure. This will give saturation pressure, and the saturation pressure what will happen? P mu, P volt T, FL, FB, and both will be cancelled because the saturation pressure they are equilibrium. So PO and P will be same. So if you calculate this P nu PO, you just see that they are same because FL and FB equals to same. So proceed for the set of calculation, same set of calculation. I won't repeat. We have to calculate again capital A and capital B because they depend on the pressure. A equals to AP by RT whole square. Capital B is BP by RT. How much it is coming? .6 699 10 to the power minus 2. Capital B is capital B is 8.77 10 to the power 4 minus 3, and then you calculate alpha, beta, gamma, and then you calculate P, Q, and all sorts of things. You can do it at home, and next class I will ask you the answer. And then calculate Z1, Z2, Z3. Okay? You calculate Z1, Z2, Z3. After that you find out, because here the D will be negative, less than 0. Okay? That means you have three solutions, Z1, Z2, Z3. And from there you find out which is vapor, which is liquid. Then calculate the paying double equation of state is there, phi L, phi B. Okay? Calculate FL, FB. Okay? And then you have the formula. If FL and FB are same, then you got the thing. So this formula actually, this what I am seeing that it is almost within iterations. Within this iteration, you should be getting the correct answer. Okay. So this kind of problem I can ask in the exam 2 iterations problem. You can do it quite comfortable. Okay. So you finish the problem, and I will ask in the next class. Next, I will be talking about effect of change in pressure and temperature on fugacity. Effect of change in pressure and temperature on fugacity. Effect of change in pressure and temperature of fugacity. So we have the formula. So we have to see, if you take derivative with respect to pressure, what actually will happen? What is the formula? If we take the derivative with respect to temperature, what will actually happen? So F by P, which is exponential of mu minus mu Ig Tp by RT, and we have ln F by P mu minus mu Ig Tp by RT. You have ln F, you can write RT ln F, RT ln P, mu minus mu Ig. Now we have the effect of pressure at constant temperature, right? That means RT dou ln F by dou P at constant T. Dou ln F by dou P at constant T. Since I said constant T, this doesn't matter. This is constant temperature. It's coming over. Okay, but if I do at temperature, then this will contribute again. Okay, this is a constant temperature, the calculus fundamental. So this is RT dou ln P by dou P at constant temperature plus dou mu by dou P at T minus dou mu Ig by dou P at T. Dou mu by dou P, you know that P, right? And dou mu Ig by dou P is Big. It's RT by P. Okay. So what did you get? Dou ln P by dou P at constant temperature. Dou ln P by dou P at constant temperature. Rahul, you are seeing something. Already solved. Okay. So what is that? Dou ln P by dou P at constant temperature. You have not got anything. You are seeing something. So that's all. Please be attentive to the class. Okay. So what is the answer? There are three terms. First term is dou ln P by dou P at constant temperature is what? Dou ln P by dou P at constant temperature. ddx of log x, ln x. Yeah, so that's what I'm actually asking for. Unless I talk like this, you won't give me the answer. RT by P plus V minus Vig means RT by P. This gets cancelled. We have V. So, interesting result we got. Dou ln F by dou P at constant T, which is V by RT. So, this is a variation of fugacity with pressure. So now you can see that fugacity, we can not only you can define, we can see the variation of fugacity with pressure and temperature. Okay, you can see the variation of fugacity with pressure and temperature. Okay. Similarly, we can have dou ln F by dou T at constant pressure. What did you get? Let's see. Who can give me the solution? I will do my way. I want the answer. We have got the answer. We V by RT for the first case. This one, this I want the answer. I want you to do that, and I want the answer. How to proceed to take the same expression? RT ln F by P exponential, mu minus mu Ig dt. You can, if you want to have, divide RT ln F, RT ln P plus mu minus mu Ig dt. If you want to do that, you can do that also, no problem. The same way, RT ln F, RT ln P, Okay, proceed. Dou T RT ln F at constant pressure, dou T RT ln P at constant pressure, dou T mu minus mu Ig Tp. And which will be, we can write this term as dou mu dou T at P minus dou mu Ig by dou T at P. Next step. What we will get to the left hand side? There will be two terms, right? Because it is varying with temperature. Last time you are lucky. This time I cannot do same way. What will you get? Current form? Pardon? RT dou ln F dou T at P plus R ln F equals to we have log ln P is a constant with respect to temperature because P is constant. We have R ln P. Am I correct? Dou mu by dou T at fixed P. Then that is dou G by dou T at fixed P. What did you get? S or minus S? Minus S. It is coming to the definition because you know that dg equals to minus S dt which is, so S you can see that dou G by dou T at constant pressure which is minus S. So you are getting minus S plus Sig. So dou ln F by dou T at constant pressure, what we do get? I want to write minus 1 by RT something in bracket. Can you fill in the blanks? So nice expression you get. Dou ln F by dou T at fixed P. Some nice expression you can get. R ln P by minus is there? R ln F by P then plus S minus Sig because minus I have taken outside. What is this minus R ln F by P? What you can write? You can write in terms of departure formula. What is the definition of fugacity? Definition of fugacity says ln F by P is exponential. Sorry, mu minus mu Ig by RT. So R ln F by P is what? R ln F by P is what? R ln F by P is what? Just one hand please. I don't know why so much of problem to give simple answer. So much of problem you are facing.
So mu minus mu Ig dt by T.
Yes, mu minus mu Ig by T plus S minus Sig. So what will you get finally? The right hand side. If you take out the T and it will be minus 1 by RT square. So minus 1 by RT square. Minus 1 by RT square. What will you get here? H minus Hig. Okay? Because G equals to H minus Ts. So departure G minus Gig is H minus Hig minus T into S minus Sig. And from that formula we can get here H minus Hig. So that's the fugacity expression. So if somebody asks you to write a differential form, we can quickly write different D and F, which is V by RT dt minus 1 by RT square H minus Hij d, right? Correct? Is that correct? Yes, because d ln f is the function of temperature and pressure. So d ln f, what is that? This is what? Rho ln f, rho t at fixed p. Am I correct? Rho p is okay. Is that okay now? Yeah. Very interesting formula. So you got d ln f equals to v by RT dp minus 1 by RT square H minus Hij dt. Okay. This fugacity definition, what you got, what I am actually thinking here, if you do massive function approach, what are the conditions you got? You have the massive function approach, thermodynamic equilibrium stability. We have got three relationships there. Massive function, three relationships. And Rahul, I gave you the problem of the second order derivative. You know those things. I think we are doing it. I think next Monday.
This Friday or Monday?
Huh?
This Friday or
This Friday or Monday you can give me. Okay. I just want to see how it is coming. Massive function approach. What are the three conditions for the equilibrium? Eventually we get the same, but the conditions coming are different. The conditions what we are getting are different. The conditions what we are getting are different. Massive function approach. You don't remember actually, huh? It is there. Yes, madam. 1 by T equals to 1 by T2. Then this next condition, P1 Pt of first system equals to Pt of the second system. Then mu by T in the first system, mu by T of the second system. Okay. These are the conditions. So when we talk about the thermodynamic equilibrium with this mu by 1 by T1, mu2 by T2, what actually will happen? Can you estimate it? For example, is it possible to have, question I am putting, is it possible to have same definition like fugacity from this massive function? Why we define fugacity? Because we saw that mu is mu minus mu I the departure, because mu minus mu I when we are talking about that is not determined. Okay, so when you go by the massive function, will you have the same definition of fugacity? That question is still unresolved. If you start from here, what you will get? You just think about it. Maybe the same, maybe different. Okay. Next part I am going to cover here, how to calculate fugacity. We have done so much of fugacity and all those. We have to feel for fugacity. If I give you a steam table, can you calculate fugacity? So I can give a question called compute the fugacity. This right now. Compute the fugacity of superheated steam. Compute the fugacity of superheated steam at 300 degrees centigrade. At 300 degrees centigrade at 8 megapascal. Compute the fugacity of superheated steam at 300 degrees centigrade at 8 megapascal. Use steam table, and when you calculate the fugacity, for calculation purpose, you need to have the formula, which is calculation del F by P, which is T tending to 0, the V minus RT by P prime. Right. So this integral you have to calculate, evaluate. This is nothing but your departure of chemical potential. Right. So the kind of data I give, P as megapascal and V hat meter cube per kg. Data I am giving 0.01, 26.445, 0.05, 5.284, 0.10, 2.639, 0.20, 1.3162. There are so much. I am giving 8, 0.02426. This middle data you can get from the studio. This is a real practical problem. This unit of V is what? Meter cube per mole. Temperature is known. How much? 300 degrees centigrade, which is 300 plus 273, 573. Pressure is done in terms of megapascal, you have to put in a proper format. Point is, you cannot take this data. So basically it says that P tending to 0, that means this data is available. Okay? You have to use numerical integration. Trapezoidal rule. You have to use numerical integration. You know all trapezoidal rule? Trapezoidal rule. All of you know integration trapezoidal rule? Yes or no? Yes? Anybody is there who doesn't know? I can explain. Yes, trapezoidal rule, you don't know. You need to have integration, right? Lower limit x0, upper limit x0. If you want to integrate, what do you do? Need to have area of this, right? Correct? So what you do? This interval is there. Along this interval, this is assumed as a linear. That means this as a trapezoid. Okay? So this side and this side you take, and this cos, this side you know, divide by 2. Okay? Doesn't matter they are equal interval or not. Unequal interval you can actually use trapezoidal rule. That's the advantage of trapezoidal rule. But the only point is, if your points are very far, this may not be linear, you may get error. So trapezoidal rule requires a lot of points. Okay? So that's so now for this table this is not useful. You need to have V meter cube per mole. And then you have to calculate your V minus RT by P, and then these values you can do the trapezoidal rule, get the final answer. You don't have to do anything on integration, you stop only these values. So how much is meter cube per mole? How to get it? Meter cube per kg. Let me have only one answer from you. Meter cube per kg is there. How much will be meter cube per mole? Quick. Water molecular weight is how much? 18. 18 gram is equivalent to 1 mole. Okay. It is meter cube per kg. So 18 kg means 1 kilomole. Correct? 1 kilomole is 18 kg. 1 gram is 1 mole. 18 gram is 1 mole. 18 kg means 1 kilomole. So what is the first term? First value. What's the first value? What is the first value? What is the first value? First value? First value is how much? How much first value? 0.476 minus RT by P, meter cube per mole 10 to the power 4. How much it is coming?
0.47.
it is there, V minus RT by P. V minus RT by P. Yeah, how much it is?
0.47.
No, V minus, how can it be 0.47? V is RT by P. R is there, no? Did you do it properly? V minus RT, how it will be 0.4?
Minus 3.9.
Minus?
3.9.
No. No, not, don't say approximately 0. 0.01 megapascal is given. Please try to be very careful. You are messing up the units. I told you so many times, megapascal is there. Pascal is Newton per meter square, right? See the unit and then go, proceed. And this, remember that this unit should be RT by P, this unit should be meter cube per mole. R is what? 8.314 kilojoule per kg per mole or something like that. Joule per kg. The temperature is Kelvin. Pressure should be such that this entire unit should be meter cube per mole. That is the way should the calculation. Don't put right the units. I am getting from the PhD students for comprehensive. If you do that, you get 0. Comprehensive exam, this is very important. You have to put the units very carefully. What's the first thing? What's the first term? What's the first term? Pardon?
2.08.
It should be negative.
Minus 1.78.
It's right side. No. No. Please do the units very carefully. I have done one part. This is, I am sure you are doing mistakes here. RT by P. It is a very simple part. Megapascal, 10 to the power 6. No. I am not getting the answer. Minus? Remember that 10 to the power 4 is there. Simple calculation are really struggling. I am seeing the class. RT by P.
So 1.7.
Minus. You should be. How much it is? Final answer.
Minus 0.17. Minus 0.17.
You don't write the units. That's the problem. I know that. When you do the calculation RT by P, what I should do? I will write the units. 8.314. Whatever, kilojoule per kg per whatever, T, this kilo, pressure, whatever pressure you have, this pressure is 0.01 and then megapascal means 10 to the power 6, Pascal means Newton per meter square, something like that, and you have to see the getting more meter cube per mole are you getting from these units. If you don't get, then your answer is wrong. Then you have to do proper conversion. You check. We never do that because our tendency is just do something very fast. Any answer? These kind of things I have learned in my BTech days. I didn't do an exam, one of the exam. They gave me 0 out of 10. And from BTech third year onwards, I learned to put unit at each line. Not MTech level, BTech level. Because I got 0 out of 10. Because I didn't do it and I got the wrong result. No answer. Minus 5. Impossible. Entire class is struggling. I am seeing that. No answer? No way. No way. No way. I think you should do that calculation very carefully. I'll give you the answer here. Minus 1.02. Please proceed, and this kind of problem may come in the exam. Thanks for your kind attention. And you